15 billion miles from Earth, a machine built in the 1970s is listening to a sound that has no business existing. It's not a signal, it's not a message, it's a hum, a low, constant vibration in the emptiness between stars. NASA scientists heard it for the first time in 2017, and they still don't fully understand it. The machine is Voyager 1. It left Earth in 1977. It has been flying for nearly 50 years, and it has barely started its journey. Here's the part that will break your brain. Voyager is moving faster than almost anything humans have ever built. And at that speed, it would still take 40,000 years just to pass near the nearest star. It may never leave our galaxy. It may drift through space for billions of years after we're all gone. And the deeper question this raises isn't about Voyager at all. It's about the universe itself. Does space just end somewhere, or does it go on forever? Stay with me. This is going to get strange. Let's start with what Voyager 1 actually is, because most people get this wrong. It's not a rocket. It's not designed to explore other planets anymore. It's a probe, roughly the size of a small car, carrying a gold-plated record of Earth sounds, greetings in 55 languages, and a diagram explaining where it came from, just in case something, someday, finds it. It launched on September 5, 1977. Its job was simple at first. Fly past Jupiter and Saturn, take pictures, send data home. It did that job, and did it well. Then it kept going. By 2012, Voyager 1 crossed a boundary called the heliopause. This is the edge of the sun's influence, the point where the solar wind, the stream of charged particles pouring off the sun, gets overpowered by the pressure of interstellar space. Cross that line, and you're no longer in the solar system's bubble. You're in the space between stars. Voyager 1 was the first human-made object to do it, and that's when things got weird. In 2017, and again in later years, Voyager's plasma wave instrument picked up something scientists did not expect: a steady, persistent tone. Not a burst, not noise, a hum. Here's what's actually happening. The space between stars isn't a total vacuum. It's filled with an extremely thin, extremely cold soup of charged particles called plasma. That plasma vibrates. And when it vibrates, it produces a very faint electromagnetic signal. One so weak it would be completely undetectable if it weren't for the fact that Voyager is sitting directly inside it, with instruments precise enough to catch it. Scientists at Cornell described it as the interstellar version of a constant, quiet rainfall. It never stops. It's just always there, humming in the dark. That discovery matters for a very practical reason. It lets scientists measure the density of interstellar space in real time, something no telescope on Earth can do. Voyager isn't just leaving the solar system. It's mapping the space beyond it, one faint vibration at a time. But here's the twist most people don't think about. Voyager crossing into interstellar space sounds like an ending, like the mission finally reached outside. It didn't. It reached the edge of our front yard. Let's talk speed, because this is where perspective completely collapses. Voyager 1 is moving at about 38,000 miles per hour relative to the Sun. That's roughly 17 kilometers per second. At that speed, you could cross the continental United States in under 2 minutes. It sounds unstoppable. It is not. Right now, Voyager is still inside the Oort Cloud's outer territory, a vast shell of icy debris that surrounds our solar system, except it hasn't even reached the dense part yet. Estimates suggest it will take Voyager around 300 years just to reach the inner edge of the Oort Cloud, and roughly 30,000 years to pass through it completely and leave it behind for good. Let that sit for a second. Voyager launched during the disco era. It won't clear our own solar system's outer debris field until the year 30,000 or beyond. After that, it keeps drifting. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of a star called Gliese 445. Not a close encounter, not a flyby, just a distant crossing in the dark. No planets. No stopping, no slowing down. just two objects sharing the same stretch of galaxy for a moment, on a cosmic timescale. And Voyager's power is not infinite. Its radioisotope thermoelectric generators, essentially decaying plutonium producing heat, converted into electricity, are losing output every year. NASA has been shutting down instruments one by one to keep the mission alive. Best estimates put total power loss somewhere around the early 2030s. After that, Voyager goes silent. No signal, no data, no hum being reported back. But it doesn't stop moving. This is the part that reframes everything. Voyager 1 will keep drifting through the Milky Way for potentially billions of years after it dies. It becomes a piece of cosmic debris, silently following a wide orbit around the center of our galaxy, alongside 400 billion other stars and everything orbiting them. And it will almost certainly never leave the galaxy. Here's why. The Milky Way's gravity is enormous. Escaping a galaxy requires reaching what's called galactic escape velocity, and Voyager, even at 38,000 miles per hour, is nowhere close. Stars, gas clouds, dark matter, all of it pulls together to keep everything inside the galaxy gravitationally bound, orbiting for the long haul. Voyager will spend the rest of eternity looping through the Milky Way, an object with no more power, no more mission, just momentum. Now, let's push the thought experiment further, because even if Voyager somehow could escape the galaxy, cross the void, and keep going, it would run into something almost too large to comprehend. Our galaxy isn't isolated. The Milky Way sits inside a supercluster of galaxies called Laniakea, a structure so massive it contains roughly 100,000 galaxies, all flowing together under the pull of something scientists call the Great Attractor, a gravitational anomaly so strong it's tugging our entire galaxy, and thousands of others, toward it at hundreds of kilometers per second. Beyond that, structures get even bigger. Galaxy clusters, superclusters, vast cosmic filaments stretching across hundreds of millions of light years, separated by unimaginable voids of near-total emptiness. This is the actual architecture of the universe, not scattered stars, but a web. And even that web has a limit to how far we can see it. There's a boundary, called the cosmological event horizon. Past a certain distance, space itself is expanding faster than the speed of light. Not the objects moving through space, space itself, stretching. Light from beyond that horizon will never reach us. Not in a million years. Not ever. It's not far away. It's permanently unreachable. Voyager, even given infinite time and infinite power, could never cross that horizon. Nothing can. This is where the video stops being about a spacecraft and starts being about everything. Scientists have spent decades trying to answer one question: is there an edge to the universe? And there are three real competing models. Model 1, a closed universe. In this model, space curves back on itself, similar to the surface of a sphere. Travel far enough in one direction, and eventually you'd end up back where you started. Not because you turned around, but because space itself loops. No edge, no wall, just a shape that folds into itself. Model 2, an open universe. This model describes space as infinite, curving outward like a saddle, expanding forever without limit. In this version, there's no edge because there's no end. Space simply never stops. Model 3, and the one most supported by current observations, a flat universe. In this model, space follows standard geometry. Parallel lines stay parallel. Angles behave the way you'd expect. And based on measurements from missions studying the cosmic microwave background, the leftover radiation from the early universe, space appears to be flat within a very small margin of error. A flat universe can still be infinite. In fact, most of the data suggests it is. So here's the answer. As close as science can currently give one, the universe most likely has no physical edge. Not because it's been fully mapped and confirmed to be endless, but because every leading model either curves back on itself or extends forever. There's no scenario, based on what we currently know, where a traveler moving in a straight line, eventually hits a wall. If Voyager 1 could survive forever, ignore galactic gravity, cross every void, and keep moving in a straight line for trillions of years, it wouldn't find an edge. It would either keep going endlessly, or eventually find itself looping back through space it had already crossed. That's not science fiction. That's the leading scientific model of the shape of everything. So think about what Voyager 1 actually represents. It's not just a machine crossing into interstellar space. It's the furthest a piece of human intention has ever physically traveled. And even after nearly 50 years, even after 15 billion miles, it has barely left the doorstep of a galaxy that itself is one grain of sand on a beach that may not have a shore at all. Voyager will go quiet in the next few years, but it won't stop moving. It will drift through the Milky Way long after every human alive today is gone, long after our sun changes, long after everything we know has changed, carrying a golden record, carrying a message, going nowhere in particular, forever. And somewhere out there, that faint interstellar hum keeps playing, a sound humanity built a machine specifically to hear, from a place we will never physically reach ourselves. That's the trade we made. We can't go, but we can listen. If this made you rethink how small and how significant that hum in the dark really is, hit subscribe. This channel breaks down the universe's biggest mysteries every single week. Drop a comment, closed universe, open universe, or flat and infinite. Which one do you believe? I read every single one. And if you want to understand exactly how Voyager has survived for 50 years on 1970s technology, that video's on screen now. Watch it next.